There are 8 what I call process standards. Process standards are not content-based, right? They're not about what facts do you know. It's more about how do you do something. They're skill-based competencies. So there's 8 of them that I'm going to be assessing you on over and over again all year long. So let's kind of run through them. I'm going to give you a little description of each one, but I want you to know that you can find this information online. So I'm going to provide you with all the details that you need to know in order to be successful. But in order to do this, you really have to read them, right? That's really the only way to truly understand what these mean, is to read them through as I go over them. And of course, we're going to go over them again and again and again. So let's start with the first one. The first one is about experimental design. So what do I want you to be able to do? I want you to be able to develop an investigation on your own, independent of me, right? So I want to be able to give you a task to do, and then you do it from the beginning to the end. You figure out what's the question you're going to ask. What is your experimental procedure that you're going to follow? What tools and equipment do you need? How many trials are you going to do? How many different ways are you going to test them? How many variables are you going to test? What analysis should you do? All of that is where you want to get to. Now I'm going to walk you through this, right? I don't expect you to be able to do it day one. This is something you're going to be able to do. You're going to start with at the beginning, and we're going to gradually get more and more independent over the course of the year. The second skill is problem solving, and I don't mean generic problem solving. I mean specifically, can you solve a word problem? So what this means is, can you show accurately, right, your solution to a problem so that someone else can read it and understand your thinking? Because I'm not going to interview you. I'm going to give you a piece of paper and you're going to have to document your work. So what work do you need to show? You need to show a sketch or an illustration. You need to show diagrams that I'm going to teach you how to do. You need to show the equations you use. You need your givens. You need labeled sketches. You need, what do you have? What information are you given in the problem? What do you want to find? If there's multiple steps, how do you show your progress through those steps in a way that makes sense to the person who's reading it? Do you have your answer with units? Did you do the right math, right? All of that goes into problem solving. 3 is data analysis. So when we do, sometimes when we do labs and sometimes when we do test questions, right, there's data analysis to do. So what parts are there? Well, that's in a totally different video. I will get into the details of what different types of analysis are there. But in short, do you make a graph? Do you do calculations? Do you do percent error, percent difference? Do you do all that correctly? Now, all the details of it I will teach you, but that's what that's about, doing the data analysis. 4, arguing a scientific claim. That's writing your CER, generally speaking, right? It's like making a claim and then being able to back it up with good, measurable data, right? Your evidence from your analysis, and then tie it to some good physics content. And sometimes you're going to do that in the lab, and sometimes you're going to do that on a test question. But either way, you're going to be backing up what claims you make with some theoretical reasoning. And this is not any different than what you do in history or in English. You can't just make a statement without backing it up, and that's what we're going to work on. But we're going to apply it to science content. The engineering design cycle is a process. So again, I'm going to teach you where you develop working models and solutions, to problems that exist, whether you're given the problem or you create the problem, right? So the engineering design process is literally a cycle. So it's not like you go through it once and you're done. You go through the process and you loop back and then you reevaluate and you start over again. And it's this iterative process that I want you to learn how to do. Not like, oh, I did it, it sort of works, I'm fine. That's not how we do things in science. So that's another very important thing I want you to learn. In CP, we're going to do this in each unit. In AP, we're not going to really work on this until the project unit. Okay, so peer synergy. Synergy is a fancy word for how things come together and interact. So I'm looking to see, how do you interact with your peers? Can you productively discuss differences of opinion? Can you help a colleague, a peer of yours do better in class? Can you provide useful information? In other words, like not just saying, oh, you're wrong, or you're right, or here's the right answer, but actually help them to learn and address their shortcomings. Because we do a lot of group work. That's actually how the world really works, right? We work with others. And so creating, that kind of atmosphere in class is very important to me. So I want to see how you create, what kind of feedback you can produce for your peers, and how do you take constructive criticism, right? And what kind of integrity do you have about the process of learning? Is it important to you to learn, or is it just important to get a grade? So I'm hoping it's the former, because that's what's important to me. I want you to leave here having learned. So that's all part of peer synergy. The seventh one is about professionalism. So how you present your work is important. That you care about spelling, that you care about grammar, that you care about neatness, that you use the right format for your products, and you pick a format that matches what you're trying to say, that you don't pick a report format for something that should be media based, those types of decisions. And that when you do record something, the sound quality is good, that you crop pictures, that you are dressed nicely, and neatly in things that you present where you're in it, that you can produce original work, and that you cite sources when you are using others' material. All of that stuff goes into professionalism. And lastly is engagement. So how do you interact with me and with the material in class? So when you're in class, do you participate? That's of course the baseline. Yeah, you participate. Well, how do you participate? Are you completing all of your assignments? Are you only working when you're in class, or do you go home and do follow-up work? Are you good at reading and following instructions, or do I need to jump in and give you guidance every time you have to have an assignment to do? Are you satisfied with the status quo? Are you always looking to stretch and grow? Are you really interested in learning for learning's sake? Are you only interested in learning just to get through the year and be done with the class? What's going to serve you in your life? And that's what's important to me. I'm looking to see what's going to help you in life, not just what's going to help you with your GPA. So all of these things I'm going to be assessing you on, and I hope that's fairly clear. If any of those are not clear, please come talk to me.